Okay, good morning class. So today we're looking at sequence and series. We'll do the second unit now, or the geometric sequences. Okay. So at this point we already know that your geometric sequences is derived or denoted with a times r, a times ar squared, ar cubed, and so on. We know that the common ratio is going to be term 2 over term 1, which is equal to term 3 over term 2, which is equal to Tn over Tn minus 1, where a is your first term, Tn is your general term, and so on. I'm looking at example 1, and example 1 is on page. Sorry? Page 8. The example 1 is on page 8. And exercise 2, so this is exercise 3. This is examples for exercise 3 on page 9. Alright. So consider the sequence 96, 48, 24, 12. The question says state the value of the next 3 terms in the sequence. So how do I move from one term to the next? How am I moving from one term to the next here? We're dividing by 2. Or we are multiplying it by half. Remember, when we work out the r value, it's going to be term 3 over term 2, which is equal to term 2 over term 1, which is 48 over 96, which is r. Okay? Never speak about dividing by 2. Okay? Because your r value is actually the ratio of term 3 over term 2. Okay? Or if you're considering the division, you must remember you're actually multiplying by its reciprocal. Okay. Alright, so the next 3 terms would be what? 6. Divide 6 by 2 or multiply by half. I get 3 and then 3 over 2. Okay. Let's look at number 2. Determine the formula for the nth term. So Tn is equal to AR n minus 1. Tn is equal to AR n minus 1. People, what is your A value? The first term? 96. Your R? So half n minus 1. You will agree with that? I can simplify that if you like. Okay, we can say it's going to be 96. But I would have left it just like that, okay? N minus 1, so 96 can be written as in products of its prime factors. You say 96 equals shift and factorize. 2 to the 5 times 3 times 2 to the negative 1 raised to the n minus 1. Which in turn would give us 2 to the 5 times 3 times 2 to the minus n plus 1. Which is 2 to the 6 minus n times 3, or 3 times 2 to the 6 minus n. That is equivalent to that. Okay? You'll get your full mark at that point already. However, if you're going to make a mistake and you use mistake in your next question, you're going to lose 1 mark. Okay? So if you're comfortable in doing this, no problem. Okay. And of course it's worth testing as well. Just test it and even make a mistake there. You can test it. If I test on term 4, there's 3 times, yeah? You speaking to her? Sorry? So half, it becomes 2 to the minus 1. Yeah. The 6 minus 4. So they give you 12, which is term 4, as you can see. Okay. People, let's look at number 3. Question 3 says determine the value of the 10th term. So n is 10 in this case. So T10 is equal to 96 into half 10 minus 1. Just put that in the calculator. It's going to be, let's put a 10 there. of course, is 192. Is that correct? Let's just put the 9 there. Oh, what did I put here? Oh, what's the name that around? So it's going to be, that should be the answer. 3 over 16. That's correct. The other one is completed. 3 over 16. Number 4. Which term has a value of 3 over 64? So what do we do here? We know that 3 over 64 is the what? The nth term of the sequence. Not so. So if Tn is equal to 3 over 64, what is Tn? 96 into half n minus 1 is equal to 3 over 64. Alright, so what do we do now in pursuit of solving for n? What do we do? How do we get n on its own? How do we solve for n? Divide by 96 both sides. That's gone. So 1 over 2 raised to n minus 1 is equal to. On our calculators we put 3 over 64 divided by 96. It's 1 over 2048. Okay. So what do we do now? You must make the bases the same so that you can equate the exponents. Not so. When bases are the same, exponents are equal. So 2048 can be written as 2 to the exponent 11. If I'm going to put the previous answer in the calculator, you won't be able to get that factorized. Okay? Because that as a fraction you won't be able to write as products of its prime numbers. Okay? However, 2048 can be written as 2 to the exponent 11. So 1 to the exponent 11 is 1. Not so? Whilst 2 to the exponent 11 is 2048. No. What can we see now? What do we notice? We can just solve for n. When bases are the same, exponents are equal, so of course, therefore n minus 1 is equal to 11, so n is equal to 12. Which means to say that the 12th term of the sequence, is going to be 3 over 60. Okay. Is there any confusion? Okay. Let's look at the next question for example 2. Worked example 2 and worked example 2 is on page 9. So here we are told that x minus 6, 2x minus 6, 5x plus 3 are the first 3 terms of a geometric sequence. So people, that means to say that that is term 1, term 2, term 3. Okay. So what is exclusive to geometric sequences? So what is applicable to geometric sequences only? The common ratio. The common ratio. What is the common ratio? T3 over T2 is equal to T2 over. Why do I use this? Because it says geometric progression. If it had said arithmetic progression, what would I have done? Would have said T3 minus T2 equals T2 minus T1. Do you see the difference? The question says solve for x. So what is T3? 5x plus 3 over 2x minus 6 must be equal to 2x minus 6 over x minus 6. So what do I do now? Cross multiply. Not so. We want to solve for x now. There's 5x plus 3 must be multiplied by x minus 6. It's equal to 2x minus 6 squared. So that's going to give us 5x squared minus 30, 27x minus 18, of course, is equal to binomial square. I square the first term is 4x squared minus 24x plus 36. Now people, if you can't do this, don't keep yourself brave. Okay? And write 4x squared plus 36. So then it will be, you will make a mistake. You won't be able to get the values out that we are looking for. Okay? You write it out twice and you multiply them. Okay? Let me carry on. So 5x squared minus 4x squared is x squared minus 27x plus 24x is minus 3x minus 18 minus 36 is negative 40, 50, 4. Okay? Is that correct? So what is that now to us? The quadratic equation. Okay, so I can do it one of three ways. No? Can either use quadratic formula. Now if you're that kind of girl that's getting the factors wrong all the time, use the quadratic formula, because that's one thing you guys can do. Okay? Otherwise, you can factorize, you factorize it. Or, for those of you who have this calculator, press mode. Did I show you already how to do this? No, here's a chance. You press mode. We're working out equations, so it's 5. And it's a quadratic equation, so it's 3. The coefficient of x squared is your a value, which is 1. Your b is negative 3. And your c is negative 54. Equals your first root is 9, so x is equal to 9. Or x is equal to negative 6. Okay. So there are two roots there. Yeah. Then the next question says, if x is equal to negative 6, which now confirms my calculation here. Can you see that? If x is equal to negative 6, state the first three terms of the sequence and the nth term. Okay, so I'm going to take this out here so that I can keep this thing in focus. So we're looking at number 2 now. So if x is equal to negative 6, state the first three terms of the sequence. So what do I do with negative 6? I put it in here. Can you see that? So that's going to give you negative 6 minus 6. Not so. The next one is going to be 2 times negative 6 minus 6. And the third term is 5 times negative 6 plus 3. In other words, it's going to be negative 12, negative 18, negative 27. You would agree with that? They want you to work out the nth term. So what type of pattern is this? Not arithmetic, is well done. Geometric. It's geometric pattern. So it must be Tn is equal to A or n minus 1. What's your A value? Negative 12. How do you work out odd? It will be T2 over T1, which is negative 18 over negative 12, which is 3 over 2 n minus 1. And we can test it. You can say, okay, let's times n to be 3 and see what we get. So it's going to be negative 12. Whoops. It's negative 12 into 3 over 2 to the exponent 3 minus 1, which is 2. What should the answer be if n is 3? For those of you looking out of the window, nice, look here. We'll put 3 in here. What should the answer be? It must be negative 27. Okay, if it's not, of course, you made a mistake. There we go. Okay, this is a way of testing. Okay, and then in the next question, they ask you if x is equal to 9, state the first 3 terms and then the general term, which means you say they're using the other solution. Okay, so what do? If x is 9, then it will be 9 minus 6. 2 times 9 minus 6. 5 times 9 plus 3. 9 minus 6 is 3. 2 times 9 is 18 minus 6, 12. 9 times 5 plus 3, 40. Arithmetic or geometric? Geometric. So Tn is equal to A or n minus 1. What's my A value? 3. What's my R? R is going to be T2 over T1, which is 12 over 3, which is 4. And as you can see, 12 times 4 is 48. You see that, people? So it's going to be 4 n minus 1. Okay? Or you can write it as 3 times 4 n minus 1. Is there any confusion? Right. Over that, we'll stop the video here, and your homework is going to be exercise 3 on page 9. Okay.